Welcome you all to the course Database Management System. Myself, Mohammad Asifuddin Mondal, Assistant Professor, Department of Computer Science and Engineering, Narula Institute of Technology. And this is lecture number 30. Here I am going to discuss about chapter 7, which is Transaction Management System. And these are the topics which I am going to cover during my lecture. First, I will discuss about the concept of transaction, means what is transaction in terms of database management system. Then I will discuss about the different kind of operation that can be performed in a transaction. Then I will discuss a very important property of transaction which is known as asset property, and then I will explain the asset property with an example of fund transfer. So to start with the transaction concept, what is transaction? So before discussing what is transaction or before going into the definition of transaction, first we have to know what is transaction. Let's consider an example. Suppose a person X wants to transfer, say for example, 100 rupees from his account A to another account B. Suppose the person X has two accounts, account A and B, and the person X wants to account 100 rupees from his account A to and different account B. And so what happened, either he or she may go to the ATM booth, or he or she can perform the fund transfer operation with the help of online banking. So whatever he choose, either going into the ATM booth or perform the online transaction, whatever he does, in the database, in the back end, what happened, the operations which is performing either in the ATM or whatever the operation is performing in the online transaction, the whole set of operation actually performs multiple tasks. For what are the tasks? First, the system have to access the customer X account A, then the system needs to read the value of account X, means the system have to check what amount the account A has. Next, it deduct the 100 rupees from account A, and then the system again read the account B to check what amount actually account B has, and then it add the 100 rupees to account B. That means in the back end, in the actual within the database, multiple operations are doing. Again I am repeating, first operation is, system will read account A to check what amount the account A has. Second, it will deduct 100 rupees, then it will read the account B to check what amount the account B has, and then it will add the 100 rupees to account B. So total exactly 4 operations are performing within the database. In terms of database management system, these 4 operations are actually performing in the backend. But from user point of view or the user standpoint of view, user sees that it's a single operation. And the operation can be termed as transfer of funds from account A to account B. So from a user point of view, it appears that it's a single operation. And what is the operation? Transfer of funds from account A to account B. But within a database system, in terms of database system or point of view of a database system, internally, actually it consists of multiple operation. First, it will read the account A, then it will deduct 100 rupees from account A, then again it will read account B, then it will add 100 rupees into account B. So these 4 operations are actually happening in the backend, means system performing these 4 operations. So this collection of multiple operations, the collection of several operations, are collectively known as transaction, and these 4 operations are basically performed in the ATM machine, in the backend of the ATM machine, or in the backend of online transaction. Actually, we perform the online transaction with the help of our mobile app or with the help of our web browser. So whenever you click the button fund transfer, at the backend these four operations are actually going on. Or whenever you click the button in the ATM machine to fund transfer, at the backend, in the backend of the ATM machine, these four operations are actually performing. And these four operation, to happen these four operation, we have to write a set of program, we have to write a program, or we have to write a code. And this program or this code consists of these four basic operations, are basically known as transaction. So this is the example of transaction. So what is transaction? A transaction is a unit of program execution that access and possibly updates various data item. So this is the definition. So what is transaction? A transaction is obviously an unit of program execution that access the various data item as well as it possibly updates the various data item. So transaction is nothing but a unit of program execution. It's a programming unit, and it executes while it is executes, means while a program executes, it accesses the various data items as well as it possibly updates all these various data items. So as a whole, this is termed as a transaction. So in that example, if we perform the fund transfer from account A to account B, it will be termed as a kind of transaction. Similarly, uh, if someone wants to check how much amount a particular person has in his or her account, then this also will be termed as a transaction, because once you click a button check balance, then what happened? The moment you click the button check balance, at the back end the database management system will execute a program, and that program definitely will access his or her account details, and then check how much money a person has, and then it will display the exact amount. So in that case, in the backend, a program unit which is termed as transaction access the account of that person and reads the amount whatever the account has, and it displays the result to the user. So it's also an example of transaction. So transaction is nothing but a unit of program execution which access various data item or the various table or various relation, and then it possibly updates all this data item, and it may show the result to the user also. And as I have mentioned, transaction is a unit of program execution. That means for transaction we have to write some kind of programming, or we have to perform some kind of coding. Now this program or this code can be either written in high level data manipulation language or programming language like SQL, Java, PHP, ASP.NET, PHP.NET. So with the help of all this language, we can write our own transaction that can be executed in the database management system. So to write a transaction program, we may use either high level data manipulation language like SQL or any other programming language like Java, C#, PHP, PHP.NET, ASP, ASP.NET, like that. PHP, not .NET, PHP, ASP.NET or VB.NET, whatever. Now another important thing about a transaction is that a transaction must see a consistent database. That means when transaction, before the execution of transaction, the database system was in consistent state. If that happens, then after the execution of transaction, system must be in consistent state. I will discuss what is consistent state in the next slide. Now during transaction execution, the database may be in consistent state, means at the beginning of the transaction the database is in consistent state, but when transaction executing, means during transaction time, the database may be inconsistent state temporarily, but once the transaction execution completes successfully, database must be in consistent state, means temporarily during execution time it may be in inconsistent state, but once it completes its execution, system must be in consistent state. So these two things I will discuss later in this lecture. When the transaction is committed, the database must be consistent. Now when the transaction is committed means once the transaction has completed its execution successfully, and once we execute a command commit, there is a command commit. So once we commit the transaction, that means whatever the updation a transaction has performed on a database, all the updation will be persist and database must be in consistent state. Now during transaction means while executing the transaction, means while executing the program, we have to issue two main things to deal with. First, as I have mentioned, transaction is a program, and the program generally execute in computer system or in our handheld devices like mobile, and these handheld devices like mobile or the computer system are electromechanical devices or electronics devices, and these devices are subject to failure. They can fail at any point of time. Failure may be occurs for maybe hardware failure, or system may fail due to power failure, or it may be fail due to software failure. So different kinds of failure may happen, means different kinds of failure are associated with our devices on which the transaction is executing, and this failure are varies from hardware failure to software failure to system crashes. So we have to address all these failure issue in terms of transaction management system. We will see it later in next lecture or next to next lecture. And another issue which we have to address is the concurrent execution of multiple transactions. Means in a system it may happen that not a single transaction, rather than multiple transactions are executing parallelly. Then there are several concerns are there. What are the concerns? We will discuss it later, and we have to manage the concurrent execution of transaction. We will see it in details later. Here I am just giving the overview of transaction. Next, transaction operation. Now as I have mentioned, a transaction is nothing but a program unit which is written in high level language or data manipulation language, and once the transaction executes, transaction basically possibly access and updates various data item. Data item means it a database like kind of thing. Now in transaction, two basic operations are there. In any kind of transaction, two basic kind of operations are there. They are readx operation and writex operation. Again I am repeating, in any kind of transaction there are basically two main operations are there. One is readx operation and other one is writex operation. Now what is readx operation? Readx operation transfer the data item X from the database to a local buffer belonging to the transaction that executed the read operation. Let me explain that. Here read is the operation and X is the data item which a transaction is reading, and the assumption is that, and not assumption, is a normal thing, is that the data item X or the whatever the database are involved in a particular transaction, all the database are stored in a hard disk. Suppose this is the hard disk, let me draw it. Suppose this is the hard disk. I am writing HD means hard disk. This is the hard disk, and suppose in the hard disk the data item or the database is X stored in the hard disk, and suppose this is RAM In short, I'm writing here. So this is hard disk, this is RAM, and suppose transaction Ti, performing the regex operation. Now what does it mean? Regex operation means regex operation transfer the data item X from the hard disk to the local buffer of to the local buffer. Local buffer means it's a place in the RAM, means that data item X is transferred to the local buffer which resides in the RAM. So data item X is transferred over here. So this is X, and suppose this is the local buffer. This is the local buffer belonging to transaction Ti. That means when transaction starts execution, whenever transaction starts its execution, the moment within a RAM a local buffer is allocated which is associated with transaction Ti, and when transaction Ti performs the regex operation, then what happens? The data item X from the hard disk will be transferred or copied to the local buffer to the RAM which is associated with transaction Ti. That means same thing is copied from hard disk to the RAM. And then write-x operation. Write-x operation is just opposite of read-x operation. Write-x means it transfers the data item X from the local buffer of transaction that executed the write back to the database. That means when transaction Ti performs the write-x operation, transaction Ti performs, let me draw it. When transaction Ti performs the write-x operation, what happened? The write-x operation, then what happened? The data item X from the local buffer of RAM of a particular transaction is copied back to the hard disk, copied back to the data item X stored in the hard disk. So whatever the updation has been done by the transaction, all updation are done on the data item X which resides in the RAM, not in the hard disk. Then after completion of the transaction, whatever the updation has been made by the transaction Ti on the RAM, so that set of data is again copied back to the data item X which is stored in the hard disk. So these two are the basic operation, read-x and write-x. And so again I am repeating that transaction, whatever the updation or whatever the modification it has been made on the data item X, all are being performed in the RAM, not in the hard disk. So after all the updation has been completed, once all the transaction has been completed, then the updated value of X is write back to the hard disk again. Now let's look at how a transaction looks like. Let Ti be a transaction that transfer $50 from account A to B. That means we have to write a transaction which actually transfer $50 from an account A to account B. For that we have to write a transaction, and let's term it as a transaction Ti. How it looks like? It looks like that. This is the transaction which is termed as a Ti. It actually transfer $50 from account A to account B. So let me explain the transaction line by line. Objective is to transfer $50 from account A to B. That means we have two accounts already. As I have mentioned, the account means it's a database, and assume that all these database are stored in the hard disk. So this is the hard disk. So this is the hard disk. So in the hard disk, account A stored over here, and account B is also stored in the database. So this is account B. Suppose account A has $100, account B has $200, so these accounts all are in the hard disk. Next, whenever transaction Ti start execution, or when transaction Ti is initiated by the user, what happen? Within a RAM, so this is RAM, so within a RAM, a local buffer will be allocated. Say this is the local buffer is allocated to transaction Ti. So this part belongs to transaction Ti. So within the local buffer, within the RAM, this local buffer is allocated for transaction Ti. Now the first operation, what we have to do, first we have to read account A. So that is why the first line is read A. Now read A means is correspond to read X operation. So read A means it will read the account A, and that means within a local buffer the account A will be copied from hard disk to RAM. That means, so this is A, and the amount will be $100. So read A means the data item A is copied from hard disk to local buffer of RAM. Then after reading, what we have to do, we have to transfer $50, means we have to deduct $50 from account A. As I have mentioned, all the updation will be performed on the local buffer of the RAM, not in the hard disk. So $50 which will be deducted from A, it will be performed over here. So 100 minus 50, now it becomes 50. So it becomes $50. So after deducting $50 from 100, it becomes $50. So account A needs to be updated. So that amount, the updated amount, should be write back to the hard disk. So perform write A operation. So write A operation means copied back the data item A into the hard disk, means $50 is write back to the hard disk. So it no longer 100, now it becomes 50. So account A become 50. So $50 is deducted from account A. Now same $50 needs to be added to the, or needs to be credited to the account B. So what you have to do, first we have to read the account B. So that is why read B. Read B means in the local buffer of RAM, the B is copied to the local buffer of RAM. This is B, and initially it has $200. Then we have to add $50 over here, means $50 is debited from A, so same $50 needs to be credited to B. So we have to perform b is equal to b plus 50. So whatever the updation will be happen in the local buffer of RAM. So over here $50 will be updated, so it becomes 250. It becomes 250, and then whatever the updation has been done, that needs to be updated on the actual data item B in the hard disk. So write B. Write B means the updated value of B is write back to the B in the hard disk. So it was 200, now it becomes 250. So this becomes 250. So that is how a transaction are performing. So read A, write A, these are the basic read A, write A, read B, write B. These are the four. This is the operation, basic operation. And for updation on the database, we can perform addition, subtraction, multiplication, whatever we want as per our needs. Next, go to the next slide, and this picture make it remain there for we need further reference. I'm not erasing that picture because that picture will be required later. Next topic is the ACID property. Now every transaction should exhibit the property which is known as ACID property, and they are atomicity property, consistency property, isolation property, and durability property. The acronym ACID is derived from the first letter of each of the four property. A from acid means the A for from atomicity, C from consistency, I from isolation, and D is from durability. Let's first discuss with the consistency property. Now consistency property, the consistency requirement here is that sum of A and B be unchanged by the execution of the transaction. The consistency requirement here is that sum of A and B must be unchanged by the execution of transaction. Without the consistency requirement, money may be created or money may be destroyed by the transaction. It can be verified easily that if the database is in consistent state before an execution of the transaction, the database must be in consistent state after the execution of the transaction also. And ensuring the consistency property of a database system is the responsibility of the application programmer who writes the transaction. Now let me explain with an example. If you go back to the previous slide, consistency property means the sum of A and B must be unchanged by the execution of the program. So before the transaction Ti starts executing, what was the sum of A and B? Initially the value of A was 100 and initially the value of B was 200. So if you add A and B, if you write A plus B before transaction Ti starts execution, in the what is the value? 100 plus 200 is 300. So after that successful execution of the transaction, the sum of AB, it must be again 300. So let's check whether after successful completion of the transaction Ti, whether A plus B is 300 or not. So after, let me draw it again. So after Ti completes its execution, now what is the value of A plus B? Let's check. A plus B is equal to, What is the value of A now? 50. What is the value of B now? 250. So if you add 50 plus 250, it becomes 300. So we can easily check that before TI starts this execution, the sum of A and B is 300. After the transaction TI completes its execution successfully, the sum of A and B is also 300, which is same. So now that means we can say that this transaction preserves the property of consistency. So consistency property requirement here is that if a database was in consistent state before an execution of the transaction, then database must be remain in consistent state after the execution of the transaction also. And the responsibility to give the consistency property to a transaction has the responsibility to the application programmer who actually codes the transaction. So what is this? Suppose this is the program which is written by any application programmer or the software developer. If instead of b equal to b plus 50, if someone writes b equal to b minus 50, instead of b is equal to b plus 50, if someone writes b is equal to b minus 50, what happened? It will become 200 minus 50 rupees, it becomes 150. So once the transaction TI completes its execution, what will be the value of A plus B? The value of A is 50 and value of B is 150. So 50 plus 150, it becomes 250. So that means once the TI completes its execution successfully, the sum of A plus B becomes 250. Initially total account balance is 300, but after the successful execution of the transaction TI, A plus B becomes 250. That means $50 is destroyed. That means it should not be happened. Then we can say that database become inconsistent state. And database become inconsistent state. Why? In that case, this is because of writing a wrong code. That means the providing the consistency property is the responsibility of the application programmer also. Next, go to the next slide again. Next property is the atomicity property. Atomicity property means either all the operation of transaction are properly reflected in database or none. That means actually we know a database transaction operation consists of multiple operation. What is the atomicity property? Either all the operation belongs to a particular transaction or happen in its entirety or not at all. That means if there is suppose 4 or 5 operations are there in a transaction, either all the 4 operations are performed or none. Means if out of 4, 3 operations are performed and 1 operation has not performed due to failure, then that should not be the case. Either all the operations are performed entirely or not at all. Let me explain it with an example. Go to the previous slide. So let's discuss the atomicity property. Already we have discussed consistency. Let's discuss the atomicity property with the same example. Suppose a person want to transfer fund from account A to account B, $50. So same example. So read A, first we have to perform the read A operation. Read A operation means the from hard disk to RAM, the value of A is copied. Then we have to perform A is equal to A minus 50. 50 rupees is deducted. So all the modification will be performed in the RAM. So what will be the value? It becomes 50. So the value of A becomes 50. Then we need to write it back to the hard disk. So write A means the value of A from the local buffer of RAM is copied back to the hard disk in the A. So A now becomes 50. So value of A gets modified, it becomes 50. Now suppose after execution of these 3 instruction, so this is a whole transaction, this is a single transaction, so multiple operation. How many operations? 6 operations are there. Now out of 6 operation, suppose let us assume that the first 3 operations are performed successfully, and then at that point of time, say power failure occurs. PF in short I am writing, power failure occurs or software crash, let's see, software crash happen or any kind of failure occurs. So what happen? So this set of instruction of that particular transaction are not able to execute. That is why I am giving cross mark. So again I am repeating, suppose out of 6 transactions, first three instructions are performed. As first 3 instructions are performed, database A is modified and updated in the hard disk. But due to power failure or system crash or hardware failure, suppose these 3 instruction, the last 3 instruction of that transaction are not allowed to execute, they are not executed. So what happened after the power failure? If you look at what is the sum of A plus B, what is the sum of A plus B after the power failure? The sum of A and B is 250. But initially, before the transaction start its execution, what was the value of A plus B? 100 plus 200, 300. So due to power failure, we are getting the value of A plus B is 250. That means $50 gets destroyed. That means a customer, bank customer definitely will be worried. That should not be the case. That should not happen due to power failure. So that means what happened? The database becomes inconsistent. Why it becomes inconsistent in that case? Due to power failure, or it may be due to system crash. So due to power failure or due to system crash, the transaction is not able to complete its execution successfully, and that is why some partial instruction are executed and some partial statement or instruction are not able to executed. That is why the database or the data item are updated partially, and that is why the database become inconsistent state, and that kind of inconsistent state is not desirable at all in any kind of transaction operation. So to overcome this kind of situation, the atomicity property introduced. Now what it says, the atomicity property, it says that either all the action or either all the instruction of a transaction are reflected in a database or none are. That means all the instructions are either reflected on the database A and B or none are. So this is the property of atomicity property. Now how to implement that? For that, before the transaction start execution or once the transaction starts execution, the transaction management system, there is a component known as transaction management system, keep tracks on the every database value. That means, let me clarify it, once the transaction start execution, the database system keep track of the old value of all the data item on which a transaction performs a write operation. That means old value of A and B are copied in somewhere once the transaction started, and if transaction does not complete its execution or in the middle point of time, if transaction failure occurs and transaction does not complete its execution, then what happens? The database system restored the old values. That means the database system restored the old values of A and B to make it appear as if transaction never executed. So that means when the transactions start executing, the transaction management component copied the old value of A and B, which is 100 and 200. So in the meantime, if the transaction is not able to complete its execution due to any kind of failure, what happened? The transaction management component will restore with the old value of A and B. That means again, so A and B will be restored with the old value, which is 100 and 200, as if it appears to the user that transaction never executed, and that is how we preserve the consistency property even during the failure of transaction. So this is the concept of atomicity property, and we will discuss it later in more elaborately. Next property is isolation property. Generally what happen? Generally what happen in a system, if a single transaction executing, then it is not a problem. If at a particular point of time in a system, if a single transaction is executing, then there will be not much problem will be there. But if in a single point of time in a system, if multiple transactions are allowed to execute, then their operation may interleave in some undesirable way, and that leads to a inconsistent state also. For example, again go to the next slide. Suppose this is transaction ti, suppose this is transaction ti. Suppose another transaction is tj. Suppose I'm writing a line over here. Transaction ti start executing fast, so first three statement is already executed. So just for recap, what will be the, if the initial value of a was 100 and if the initial value of b was 200, let it write 200, and after the partial execution of ti, what will be the value of a? I'm not repeating again, just I'm writing directly value over here. So the value of a will become 150 and the value of b will be remains 200. Already I think you remember it well. And so after this this execution of this instruction of transaction ti, suppose tj enter into the system. So that means in our system we have two transaction ti and transaction tj. So that means in a single system at a single point of time we are having two transactions. Now what will be the problem here is that suppose transaction tj, this transaction only reading the value of a and b, means it access the value of a and it reads the value of b. And again I am telling that transaction tj start execution from at that point of time. Transaction tj starts executing from at that point of time. So ti already executed and it made updation on a, yet to be updated on b, but at the meantime tj enter into the system and start executing. And what tj does, tj reads the value of a and b and it displays the result to the user. So what happened when, if tj reads a and b, it sees the value of a is $50 deducted, but it also see the value of b is 200. Why value of b is not updated? This tree instruction is needs to be executed by ti, but tj already entered into the system. So tj reads the value of a and b. So what happened, tj will sum of a and b, it will becomes 250 and it will display to the user. But this is not the actual value, it should be 300 but it becomes 250. That means as if user presume that the $50 is destroyed. Why? Because ti and tj, two transactions are executing concurrently. So that means we can conclude that if more than one transaction are executing in a system, then system may become inconsistent state if there is no coordination are there between the two transactions. That is why the isolation property was introduced. The isolation property of a transaction ensures that the concurrent execution or simultaneous execution of transaction result in a system state that is equivalent to a system state that would have been obtained had this transaction executed one at a time in some order. And ensuring the isolation property is the responsibility of the component of a database system, which is termed as concurrency control component. That means the concurrency control component is a part of database management system, and that concurrency control component has the responsibility for ensuring the isolation property. So what is the isolation property? Again I am repeating, it's a property of a transaction which ensure that the parallel execution, the simultaneous execution of transaction produce a system state which is equivalent to a system state as if the transactions are executed one at a time in some order. That means even if the system executed simultaneous transaction or multiple transactions simultaneously at the same point of time, but again it will produce a system state as if these transactions are executed serially one after another, and that kind of thing can be achieved with the help of concurrency control component. The next property of the ACID property is the property which is termed as the durability property. It says that after a transaction completes its execution successfully, then the changes a transaction has made to the database persist even if there is a system failure. That means if the transaction completes its execution successfully and it already made updation on the database, then if the database system crashes, the database system crashes means it may be a hardware failure occurs or whatever it be, then also the changes whatever it has made to the database should persist even if the failure occurs. So this is the concept of durability, and this is the example of fund transfer in terms of ACID property. All these things have already discussed. I'm not repeating it here all again, and these are the references. You may go through it for more details about the transaction management system.